So it turns out I had a problem with the data being sent to the pixel shader or some code in the pixel shader. So in my application, I had a line here that was commented out that was sending some data to the pixel shader. And in the pixel shader from previous transparency demo, we had this bit of code here that was using this alpha value. Well, if this alpha value was really small or 0, then we get everything being transparent, so we weren't seeing anything. So I've commented this out, and I'll just move the camera around a little bit to get a better view. And remove this rear billboard. And when we render this, we see that we have 4 spheres and a single fabric arm here that's only 100 units long. Let's make that a little bit longer and talk about how it's going to move. So we create the fabric arm. Let's make it 500 units long. And then what we'd like to have happen is when we point to or click on a particular sphere, we'd like that arm to move, change its orientation to go to that sphere. And that brings up the picking part of this particular program, similar to what we've seen last week. So for that, when we catch a mouse message, in this particular case the left button down mouse message, we get the XY position and we call this picking function. And I'm also setting this additional parameters. The W parameter is doing a bitwise AND with the control key. So this is going to return true if the control key is pressed, and it's going to return 0 or false if the control key is not pressed. So then in the picking test, we are going to create our ray and ray direction just like we've seen before, with one big exception, and that is the world matrix is set to the identity matrix. And the reason for this is we're going to intersect this ray with what we refer to as a bounding sphere that is set with the sphere's world position and world radius. So we don't need the world transformation anymore because the bounding sphere is going to be not in local coordinates but in world coordinates. So we can create the ray then in world coordinates rather than local coordinates by passing in an identity matrix for the world transformation. So we create the ray just as we did last time, and then loop through each sphere in our sphere list and create this bounding sphere. And a bounding sphere just has a center, a position, and a radius. And this is again in world coordinates. Now instead of asking if the ray intersects a polygon, we're asking if the ray intersects our bounding sphere. And if it does, we compute this hit position. And if the ray hit and the control is pressed, we're going to move the arm to that particular position. If the ray is hit and the control is not pressed, we're going to set that sphere position as the target position. So what that means is we can move the base point of our fabric arm as well as the target that we want that fabric arm to point to. So let's see if that works. back the camera up a little bit. So I'm going to press the control key and select one of my spheres, and you see the arm moves, the base position of that arm moves to that sphere. Now I'm going to choose another sphere, and the arm animates to try to touch or point to as best it can. Now since this is just a single arm that doesn't have any joints in it, it does its best it can to touch the point that was selected on the sphere, but can't really bend to touch it exactly like we want. So for that we need to add multiple, and in this case it doesn't even reach. So now we're going to add multiple arms in here. So I'll go back to the initialization of the Fabrique arm, and let's make it have 3 arms of length 200. And actually, while I'm at it, let me back this camera up even more. Still could have backed up more, but now you can see that the arm is made up of 3 segments, and if I click on one of these spheres, it will bend and articulate in order to touch the sphere as best it can where I clicked on. And this is, again, using the Fabrique algorithm. Every frame, and there's lots of frames per second, every frame it is running through a single iteration, a single backward and forward iteration of the Fabrique algorithm to approximate the location, the pose, or the orientation of each of those arms. So we can have some fun here and make a lot of different arms that are smaller. And so I don't know if you can tell, it may be difficult to tell, but we have a lot of different arm segments in here, 100 of them. And now it almost kind of snakes around toward whatever point we touch with our mouse. So you can get some interesting effects with this and use your imagination to create some interesting animations with this. There is a note to make on the performance. Notice our frame rate has dropped substantially. I'm not sure if you noticed, but in the code we inherited the Fabrique arm segment from the poly object. And so each Fabrique arm segment has its own cylinder, and each one has its own texture, even though those data are exactly the same. So the cylinder is the same, the texture is the same, the cylinder is being transformed, but the actual vertex data and index data for all the cylinders are the same. They're just transformed in different ways. So as an improvement, we could modify the Fabrique arm to contain just a single cylinder, and instead contain a list of transformations for each one of the segments. And this would save us on the data transfer to the GPU, and save us on changing the texture map every time, even though it's the same one. So there's some performance improvements that could be made, but these are the basics of the algorithm in using Fabrique to solve for a pose of a multi-jointed arm. So that concludes this presentation on animation. Let me know if you have any questions.